Okay. Close the door here. What's up, everybody? Hope you're doing all right. Welcome back into the stream today. Starting a little bit earlier today than normal. Feels good. Back in the routine. Want to keep going on our C programming here and keep chugging along. Hey, Cav, quick in here. Thanks for joining me. Appreciate you coming in so quick. You're awesome, my boy. Welcome in. Okay. Hello, everybody. Welcome back. So today should be a fun one. We're going to be jumping back into C programming, chapter 11, pointers. We're going to be jumping into taking a look at some more of these exercises and trying to complete them. So welcome in. Saw the Discord ping. Hey, let's go. I was wondering if anybody actually uses those in the Discord. I thought that maybe the people that think they were annoying or something. But awesome. Glad that you used it. Welcome. You're awesome, dude. Okay, let's go ahead and get started for today. So yeah, we're going to be jumping back into C Programming, A Modern Approach, second edition by K.N. King, as the title says. Can I move that over so you can see me a little better? Yeah, we're going to be jumping back into this. I just don't want my computer to fall off the edge of my desk. That'd be really bad. Got that Apple Care though. Okay. So I'm going to need your guys' help, so welcome back in. Big shout out to Daniel yesterday and John for helping us out with kind of better solidifying our understanding of pointers and, helping us complete the first half of these exercises. So feel free to help us out in the chat here. Or, even if you don't know the answer, try to answer some stuff and, try to learn alongside me here as we solve these. So we're working on 4 through 8 today to wrap up the exercises. And then I haven't decided if I still want to keep going with the programming projects on stream, because it does take us a while to get through the chapters and kind of move on to more subjects. Um, I still definitely want to complete the programming projects, but it might be a better task for me to maybe complete those off stream, in kind of more of a relaxed setting. I can kind of complete them anywhere, work on them in my downtime. Where so just to help keep the pace moving along, or would you guys rather me do the programming projects on stream? And do everything on stream like I have been. So let me know. All right. Well, we're back here. Chapter 11. I'm going to be looking at number 4. Or number 5, I mean. We're going to be doing 5 through 8. So let's go ahead and give this a stab. Okay. Write the following function. All right, we have a function called split time that returns no value. It takes in a total second variable and 3 pointers, hour, minute, and second. We have a total seconds as time number of seconds, right? This is a long integer. Then we have pointers to variables, which are integers. And we want to store the equivalent time in hours, 0 through 23, minutes, 0 through 59, and seconds, 0 through 59. Cool. All right. So let's go ahead and try some stuff here. So let's just get going here. We're going to include the standard io.h kind of tag here, or include that header file. Let's just get this going by first writing this function here. So void split time, all right, which is going to take in a long total seconds, an int pointer called hr, a int pointer called min, and an int pointer to seconds. Cool. So we'll open that up and then we'll kind of do that. So then we have a main function here, which is going to go int main void. We're going to have total, we'll have a long total seconds is equal to, we'll just make this some very, we'll say 60,000. I don't know, probably not in the long, but whatever. we'll just kind of temporarily do that. And then we have pointers, right? We have int star hour, star minute, star second, right? Hey Jimmy, yeah, we're talking. Yeah, welcome back, boy. We're finally getting some tools under our belt to maybe do some real programming here. So, welcome in. What you've been working on lately? Welcome back. Okay, so we have that. We're gonna call our our split time function for total seconds here, hour, minute, and second, right? And then we're going to obviously print. We'll have a printf here, and we'll do some stuff when we get there. Okay, just some boilerplate here before we get started. Now, for this problem, off the top of my head, I kind of want to use a modulo. That's the first thing that's kind of giving me some the feels is the modulo operator. I wonder what you guys think. Yeah, I have a Discord channel link down below. It's got all of my resources in it. I'll be honest, I haven't done a great job of adding a lot more of the resources recently, as a lot of these resources we've actually been taking quite a lot of time on. These books have been getting into them, and so not a lot of new content per se in terms of actual like channels and whatnot. So, but there's a lot of great stuff for kind of getting started up to this point. I have everything from this point back. So, yeah, it's just it's not really evolving that fast because we're not learning super fast as we're kind of learning more and more or harder material, and it takes a little bit longer. Okay. Cool. So now we have total seconds, which is a long integer. So we know that hour, 23. So we're trying to figure out how many seconds in this we can make hours, right? So if we divide by 60, we would get, the amount of total hours. But is that the problem that we're looking for here? We'll store the equivalent time in hours. Yeah, so we want to find the total amount of time, this is in seconds, in hours. That will give us the remaining amount of seconds. We want to find how many total whole minutes we can make out of that. And then out of that, we just have a remainder of amount of seconds left over. So we have int remainder of seconds, which is going to be equal to total seconds mod by, right? Now, this is in seconds, so we can't mod by 24 because that would be hours. So there's total seconds, we want to make total hours, so this would be mod 60, right? Now, that would give us back the remainder of doing total seconds divided by 60. How much can 60 go into total seconds and the leftover amount of seconds, right? So now that would give us the amount of seconds, right? Now what we could actually save this as is, if we want to be fancy here, this could just be, right, the value of the HR pointer. And we could save it like this. Now, what we can do is do, so now we have the amount of hours, total seconds left, which is saved. No, we don't want to do that, sorry. Wait, that gives us, yes. And then we want to take total seconds and do less equal by the amount that we just calculated at the value at pointer HR times 60, right? So we need to multiply that value, right, which will be in whole hours, times 60 to get it back to seconds. Oh no, that's by minutes, right? 60 minutes in an hour. So hold up, 60 times 60, so this would just be my fault, right? It'd be this, right? Or what is that? Is that just 1200 off the top of my head? I can't do math that well. 3600. 3600 seconds in an hour? No, in a day, right? Yeah, an hour. So 3600 for the amount of hours, whole hours. Now this would be times 3600, so you get the amount of total seconds we need to remove, right? Now we have total seconds is still containing the amount of seconds left over. Um, right. So we want to we want to it's not pointing to anything though, that's right. So how about I just make int hr, int min, int second, and then pass in the address. Would that technically be the same thing? Right? So if I just pass in the address on int variables themselves, and then the addresses will be captured here because that's what we're expecting is addresses. Now these aren't pointers per se, but like this is kind of expecting pointers, but you can kind of say we're expecting addresses here maybe in lingo. And I'm not sure if that's the appropriate way to say it, but okay, so we have the amount of hours is captured here, whole hours. We take the amount of whole hours and multiply it back by 3600 to get the amount of total seconds that's left over, right? Then we can capture it in the value at minute is equal to the amount of total seconds mod by 60, right? So this will pull out the amount of whole minutes out of the amount of seconds. Not times 60, sorry, mod. This is in total seconds. This is in yeah, 3600 seconds per hour gives us the amount of hours. Right? Am I thinking about this the correct way? So then we have the amount of minutes left over, and then that would just give us that star seconds is equal to the total seconds now less than whatever value star minute times 60. Let me do some math over here on this little calculator. Let me do, let's just say we have a dummy value of, let's just say we have 6,000 seconds. And we're going to mod this by 3,600, which should give us 2,400. Oh, what? Hold on. 24. See, I always get confused on whenever I use the module, though. I always have to kind of go back and do the math here. Let's see here. So 6,000 mod 24 is 0. So this is saying... I thought this was saying how many times can 24 go into 6,000. Oh, shoot, I was doing the wrong thing. Oh, yeah, because it only goes into it once, and you have 2,400 left over. Right. 3,600 goes into that once. So then why would 24 be 0? Because there is no remainder because it goes in evenly. That's right. Module always gives my brain just like a workout every time I use it for some reason. Okay, so if that's the case, if that's the case, let me so that if that's the case, then okay, hold on. So let me see here. We have total amount of seconds. We either need to get this into total hours or do something here, right? Now let me. I need the modules. Ah! 6,000 evenly divisible by 24. That's the result. So then how could you get it back if you wanted to know how many? Remainder would give you how many seconds are left over. So let's give you how many seconds are left over. So then we would take the total amount of seconds. So if you do mod, let's say we have an input of 6,000. You mod by 60. Let's just change it so it doesn't go in 0 evenly. Let's just change it to like some random value here. 12. Yeah, so this would be 60 seconds per hour, right? So it's total seconds divided or multiplied by 60 would give us the. But I'm trying to think about the units here. I don't know why this is so annoying for me. But So if we have a value of like 4572 and divided by 60, that would give us a remainder of 12, right? 76 is the integer quotient, the value of with a remainder of 12. And so the remainder of 12 would be captured here. Now, would that be hours, or what would that represent in that case? Because this is just 60 seconds. And what does that make up? 1 hour, right? And this is total seconds. So yeah, I think that would make up the total amount of hours would be here in the remainder. But what if this is 0, right, in terms of the remainder? So I don't think we want to save that directly here. I think we need to I think we need to, I want to get a piece of paper, but I don't think I have. I might. In my backpack. Let's see. I might have a book. I thought I had a piece of paper. Let me see if I can find it. No, I don't have a piece of paper anywhere. I have quick access. Oh, well. My lag. No, it's not someone. Okay. So we're back here. Hold on. So if we have a total amount of seconds, and we modulo to get the amount of hours, that would give us, yeah, we have to do the total amount of seconds in an hour, which is 3,600 seconds. Right? I think that's what it would be. I just already afford it. Okay. So was I right originally in the fact that you can have, this gives you the amount of, not, this isn't the amount of hours, this is it left over, right? Right? That'll give you the amount of leftover seconds, but you need to know how many whole hours were made up out of those leftover seconds. So you just have to do star HR is equal to the total seconds less than the leftover divided by 60 seconds per hour. That'll give you whole hours, right? Minus the leftover divided by 60. Let's think about it. So you have total seconds of, like, let's say 4,700 or 4,572. You mod by 3,600 to get the amount of total seconds left over after making whole hours. You take the total seconds minus the amount of leftover seconds, and divide that by 60 to get whole hours. Now you have leftover seconds. Right? And you can do a same thing of leftover is equal to we can just use this variable again. Leftover seconds. Right, and so this would be leftover mod by 60 to get you the amount of individual seconds left over. We can capture this and just star seconds, right? But we have to compute something like star minutes is equal to leftover less than star seconds divided by I guess it's whole seconds, so we have to divide by 3,600 total. And then divide by 60 here as well as the mod. Divide by the mod that we're doing. And is that it? I don't know why the mod is so a struggle for me, I'll be real. Let's see what happens here. Amount of hour. Yeah, this is probably going to be a big time fail here, so bear with me here as we're trying to learn this. What's going on here? Let's see this guy. All right, let's try it. GCC. Dang. Oh, whoops! I forgot to finish that. Printf. And direction requires pointer operand int invalid. Oh, because these are just valid address. Okay, so these are just these aren't pointers. These are, we're just inserting these values. We actually overrode, use the addresses themselves. Okay. 16 minutes, 16 hours, 40 minutes and 0 seconds. And 6,000 seconds. Did we get it? Let's try our little dummy value that we were testing with over here. 4572. Let's try it. 1 hour, 16 minutes, and 12 seconds. Oh, I think we did it. Let's go. Oh. Honestly, I did not have much faith in myself there. I'm going to be real. But that is really awesome that we got that. Right, so the part that I had to remember, so we had to figure out, remember we're in seconds here, we could have converted, we needed to make sure that we have our units correct when trying to calculate the hour. And then you also have to, this just gives you the amount of leftover, so you need to remove the amount of leftover and divide by the, the value to get your total hour, right? This just gives you one step in the process, and then a similar kind of makeup here. So, I mean, we probably could have wrote another function here for this process because it looks like a similar thing, but okay, now, nice. Oh, got you. Yeah, James, we can just do the value number of hours times 3600 plus. Yeah, just kind of. It's interesting because I kind of read that as like a polynomial at first, if that's even applicable. So, but we don't have a powers or anything on applicable there, so it's kind of like I was like, what? Oh yeah, yeah. Okay, I think we're good there. That was number 5. Nice, good job, guys. Way to come together on that as a group here. Okay, here we go. Number 6. Here we go. Write the following function. Another function problem. Here we go. I think we're functions for the rest of these problems here. Void find two largest. Int, so we have an integer array A. We have int n, which I'm assuming is the size or the length of the array A. We have int pointer to largest and int pointer to second largest. Okay. This one's easier than the last one, I think. Okay, so let's set up this. Let's keep this going. So I know we have to do this always, but include the standard. This is stdio. We're going to do, okay, let's do void find to find to largest. It's going to take in an int array, right, an int n, an int star largest, and an int pointer to second largest. Okay, and we'll come back to this. We're going to have int main void. We're going to have int largest and second largest. And then that'll do. We'll call our find two largest function, pass in. Oh, we need an array, right? So we need int nums array. We also need an int variable for the value, so I'll say n here, which is equal to, let's just say, actually let's do our thing here. So let's just say that we have some ints here. Let's just do 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we'll add the 0. 0 through 9. Okay, so let's do that one thing that we can do, right? So let's define that int n is equal to oh god. So I'm trying to dynamically set the length of this array without putting a magic number in here. I know we need this size of, right? And this will be whatever the value of num's index 0 will be. But what are we dividing? That's in our denominator. What's in our numerator? Who's got that for me? Who is an angel out there and's got that for me? I'm not sure why I did that. Like I'm Python. There we go. Okay, so you can call. I forgot that. You can call size of on the actual nums array itself to get the size of the entire nums array. So yeah, you do have to find the sum of the array. I was thinking, I'm like, we don't have to loop, do we? Okay, so it's size of the nums array versus size of index 0. Okay, that'll give us that. Okay, so we're gonna find two largest by passing in nums n largest and second largest. And what we need to do is pass in these expecting pointers, which is addresses. So we're passing the addresses of those guys. Almost got me there. Then we have a printf here that we'll fill in when the time comes, but we'll just say largest. And we'll say second largest. And then we'll go like that. Okay, sweet. That's set up. Now we can write our function. Cool. So let's be a little bit overkill. Let's be annoying. Let's be that guy. Let's go ahead and use two pointer. Right? Let's do it. So for int I equals to 0, while I is less than well, should we not do that? Should we not be annoying? Should we just why don't do it to ourselves? Let's just we have to check largest, then if largest gets overridden, then second largest gets put by default. So actually it's just a singular check on largest, and then that gets pushed off onto second largest. So we kind of can just fill these values prematurely if we need to, but we don't necessarily know what the size of the array is. We don't want to skip over the first two numbers of the array or assign those prematurely. So probably should do a loop or whatever, but I might be getting too overkill here too. So let's just do I less than n. Oh, these, is it semicolons here? Not commas? I always forget. So we have I0 here. If array index AI is greater than the value at largest, which isn't actually assigned to anything here. So do we bite the bullet and just assign them to the first two values of the array I, no matter if array doesn't have two values, or do we set them to some very large negative number, or do we set them to um, or do we loop twice through and set them for the first two values if and then use a counter for, or do we just an if conditional? Or is this just being too much of a fuddy duddy? I'm trying to nitpick this. What do you guys think? What's up, Greg? I like that pick. That Zelda pick. Okay. Well. Right, because what if these garbage values happen to be large? Or they might not be anything. So I say if I is equal to 0, I is equal to 0, right, we want to set the value at largest equal to a at index of I. And then what we're going to do is continue on this here. If I is equal to 1, right? If I is equal to 1, we need to do a check if the value here at index of 1, the second value in the array, is larger than the larger value in there. If it is, then we're going to do a push off. We'll do, well, at this point in time. So maybe actually all you need to worry about is setting the largest to the first value. And then second largest will just naturally fall into place if there is one. But is it safe to assume, though, that largest can be set to array at index 0? And then we can loop from 1 forward and then do the evaluation. So, like, if the value at largest is greater than, is less than the value at, is less than if the value at array index of I, if the value at largest pointer is less than the value that we're iterating over, then we know that this value that we're iterating over becomes the largest value, and the second largest value is now overridden by the previous largest value. So star largest, or say second largest is equal to largest, star largest, and then star largest is equal to array at index of I, right? Else if, right, star largest is greater than the array at index of A, and the array at index of I is less than the second largest, then second largest, with star second largest, then star second largest is equal to array index of I. Right, so this is the case where if the largest is trumped, then second largest is also trumped. So we can just do a dual shift of both of those values down. So the array of index of I goes down to largest, largest goes down to second largest. Well, what happens if you're sandwiched? Largest is greater than the current value of A index of I, but second largest is less than the value. So this needs to replace second largest. Now, in the case where A is below that one, or A at index of I, that doesn't fall for any case we care about for this function for the first and second largest. So I think that's done. Okay, cool. So we just did this in linear time using a single pointer. We didn't care about do a double pointer. So else, I guess else you just continue, right? Nothing else happens. All right, let's give it a try. Done. Whoops. Boom, boom. Boom. What? I thought I got that. Oh, here. Expected expression. Oh, it's not my for loop. Whoops. Syntax errors, my bad. It's not actually our logic, it's just syntax errors here. So give me a little break, give me a little break. Let's go. All right, that'll do that. That's an interesting point, inventive genes. So what if there's two values in the array that are the largest and they're the same? Okay. So if the largest is less than, oh, that's interesting, right? What if there are two values that would be 9 in this array? We wouldn't get them here, huh? Largest is less than that. I could say this largest. Okay, we just have to have a less than or equal to. So less if it's less than or equal to here. Would that be the simple fix? No way. Right, so if it's less than or equal to, we'll still shove off the largest and the second largest off and push those down. So if we come across that second 9, we'll still push the largest down to the second largest in this case here. Thank you, Inventive Genes, for that. That was a good follow-up. Okay, then let's go ahead and make sure that this does work still for just having those. All right. Cool. Good job, you guys. Number 7. Write the following function. Void split date. Int day of year, int year, int pointer month, and int pointer day. Split date. Day of year is an integer between 1 and 366, specifying a particular day within the designated by year. Specifying a particular day within the year designated by year. Month and day point to variables in which the function will store the equivalent month 1 through 12, and within that month 1 through 31. Oh, this one sucks because there's like the leap year edge cases. Wow. Void. Day of year. Int year. Int month. Int day. Okay. Okay, so for this one, we have days of year. Well, first off, we need to figure out is if this is a leap year. We'll include the standard bool. We'll define a boolean as leap as false. So leap is false. So if year mod by 4 is equal to 0, right, then leap is equals to true. Right? So if the year is divisible by 4, then I think that this leap year goes to true. I'm really bad at dates and stuff, so I think that that's the rule, right? Is that it's every 4 years is a leap year. And so that means that February would have 28 days in it. Right. So let's write an array for how many days. So, yeah, right? So let's do int, we'll say calendar is an array, and we'll size it, we'll do this. So January's got 31 days in index 0. February typically would have 30. Is it 30 and then in leap year it's 28, or is it 29 and 128? What is the thing? Days in February, 28, and leap year. I think it's 28 and 27. 28, 29, other way around. Oh, also it says that, however, years divisible by 100 are not leap years as well. And year mod 100 does not equal to 0. Right, so the year divided by 100 cannot equal 0. So we can kind of overload this, I guess, by placing this one first. To do that check first, make it a little bit better. Doesn't really matter, whatever. Unless it's divisible by 400. Oh, okay, so there's an additional rule. Gosh dang, dude. So if year is divisible by 100, not divisible by 100, but it can be or the year mod 400 equals to 0. So the year cannot be modded by 100, but it can be modded by 400. That statement has to come out to be true on that left side. So yes, it can't be modded by 100. No, because then that's an or statement, which will mean that it has to take place. So this kind of needs to be its own separate check rather than it being encompassed in this. So if this happens, right, if this happens, well, first off, the year has to be divisible by 4. So let's just keep that one out front like we had, right? Has to be divisible by 4, and it cannot be divisible by here, but it can be divisible by this. True. So let's just say this is a leap year. So true. Let's say this is a leap year that is modded by 400. If that cannot be true, the middle statement, year, well, that has to be true. It can't be equal to 1. It can't be modded by 100, evenly divisible by 100. So if that's the case, oh, come on, think. You got this. You're right there. So if that's the case, they can be. It's true. And that has, so both of these statements have to be true here for that to work. But then, would it be an and or an or? Or would we even really want to do this one if you're one? Well, let's just, I mean, if you say this, right? If it's either this or this, it has potential to be a leap year, right? So if either or of these are true, it has potential to be a leap year. But in order to clear for the final case, it has to also clear through year mod 100 cannot be 0. That might be the better way of thinking about it, right? So it can be either one of these cases to potentially, okay, it might be a leap year. It's modded by 4, which is 0, and it's a mod by 400 equals 0. No, it's the other way around, right? This trumps this in what it does. So like and unless it's mod by 400 is equal to 0. So the year mod 4 has to be equal to 0. True for this statement. Okay. Now the year mod 400 is true only if the year mod 100 is equal to 0. So this has to be true, and the year mod 400 is equal to 0. So both those would have to be true in order for that to pass. Okay, so if the year mod 4 is equal to 0, that would mean that we have potential to be we've passed our first check. I know we could write more nested if statements here, but I'm really trying to kind of use the logical operators here that we have in the conditional expression. So if the year mod 400 is equal to 0, that means that it's to be pointers to pointers, everyone's favorite. Nice, Zen. Welcome in, dude. How's it going? So if what if we make this equal to 0? So if this has to be true and that has to be true at the same time. But that would make it so that it has to be like a specific thing. If it's divisible by 4, which is true, so maybe this is an or. Well, that would happen a lot. However, years divisible by 100 are not leap years unless they are also divisible by 400. However, a leap year is indicated true if it is divisible by 4. However, years divisible by 100. I mean, like, what if we did this? Like, we could say this. If this, right? Then you could say if the year is divisible by 100, that equals to 0, right? If it's not equal to 0, then leap is set to, well, if it is equal to 0, then leap would be set to false here, unless what if you write it's blah 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 Shane? You say like, well, in this case, leap is equal to true. Okay. Well, you can say else if year mod 100 right is not equal to why do I suck at this? Who's got a hint for me? So I don't want to give up on the conditional, like, longer one expression, but slowing down here, a long day of work. That's my excuse every time, right? So if the year mod 4 is equal to 0, then leap is set to true. Well, else if the year mod 100 is equal to 0, if the year mod 100 is equal to 0, then leap is set to false. But if it is so dumb. Okay, so dumb. So if year mod 4 is equal to 0, right? And year mod 100 does not equal to 0, so okay, that's true. So either or of these have to be true for a leap year to be kind of considered maybe a leap year, right? These are the for sure things that have to happen. If this doesn't happen, we need to evaluate now both of these things need to be true. So the year needs to be divisible by 4, and it cannot be, right, that's what it says in our definition. Let me go back. A year is a leap year if it's divisible by 4. However, years divisible by 100 are not leap years. So if you think about logically, a year is a leap year if it's divisible by 4 and not divisible by 100. So a year is divisible by 4 and not divisible by 100. Okay. Yeah, I'm glad I didn't go then.
It wasn't hard. I just ate too much before.
No, I'm on stream. I'll talk to you afterwards. Okay, and so right? If both of those have to be true. If that turns out to be false, meaning that, okay, it's not one of those years, but there's one specific year case that it also is, and it's if it's divisible by 400. So that's the or there. So it's if year mod 400, right? So if that happens, leap is equal to true. True. So we have, and we don't even really need bool leap here actually. We just need to override the value in our array here to 28. So cal index of 1 is equal to 28. So that's February, March, April, May, June, July. Now here's where I get tripped up. July and August both have 31 days, right? June, 30, 31 in July, 31 in August, 30 in September. Yeah, that's right. 30 in September, 31 October, 30 November, 31 December. Oh, the leap year is 29. See, this is where, I'm sorry, I'm trolling. The leap year adds another extra. No, I thought the leap year you save a day. Oh no, you get another day. That's why people make such a big deal out of it. They take the day off work. Oh, I get a free day, like to do whatever I want. Okay. You get an extra day. But in a leap year it gains. Okay, cool. Okay, so that'll override that. So then we have the day of the year. Okay, so then for int I equals to 0, well, I less than the size of all right, well, I is less than the length of the array cal. We'll increase for us. We'll iterate over our array of months, days and months. We will then say we need to figure out which month we're in. Right, so we have to say if day of year less than the cal index of I is equal to 0, meaning that if we remove the total amount of days remaining in this day of year, and that is equal to 0, or sorry, is less than or equal to less than 0, we know that we're in this month somewhere, right? if it's equal to 0, we know it's the last day of the month. And if it's greater than 0, we iterate. So if it's equal to 0, so let's just do this. We'll say int remainder is equal to remaining days is equal to day of the year less than cal index of I, right? So if we say that the remaining days is equal to 0, right? If the remaining days is equal to 0, then we know that the month is equal to I plus 1. And we can say star month equals to I plus 1, because I is iterating over our count of months. Day is equal to right, our day is equal to our day is equal to, sorry, where was I? The actual value at cal index of I, right? The 31st of whatever month. 30th, it's the last day of the month. Now, if it's negative, we're still in this month, and we need to find out which day. Well, that's kind of easy because we can just do the difference between the last day minus the current day to find out the days left to figure out which day we get on, right? So if we have 11 days left, if we have 10 days left to count into March, let's say we're going to get to March 10th, we can take 31. No, that would give us 20 as the value, right? 10 days left. Well, then it would just be 10 days. So we'll say else if remaining days is less than 0, then month is equal to I plus 1, and day would it not be just the, so let's say we have 10 days and we're just starting a month, so 9 left after the first. So 10th would be our final day, and so it would actually just equal 2 remaining days. Right? Else, if you're greater than, in the final case, right? If you're greater than in the final case, you need to move on to the next month and take out day of the year is equal to the amount of remaining days. Now, what we can probably say, this gives you a year though, so you don't need to worry about looping over to the next year and increasing that year value. You're given a day of a year and the year in that day, a day of the year and the year. So you're not, it's bound to that year parameter. So there's no like, cyclical looping we need to do here. Anybody think of anything else here? So we determine if the amount at if it's a leap year, we adjust it accordingly. We calculate how many days are remaining after accounting for the month that we're on. If we've exhausted all the days, then we know that this is the last day of the month. If we have negative days, then we know that we're inside the current month, and we can just use the amount of days left as the days of the month. Else, right, the day of the year becomes the remaining amount of days left for the next pass after we've already gone through this month. So then if we call a int main void function here and do, right, we have day of a year, we'll do 306 int day of the year is equal to, let's do 365. One of 366. 366. Right? We have int year is going to be equal to 2026. We have int month and day. And then let's call split date for day of the year. The year, the address pointer to insert as a pointer of the month, and the address of day. Let's then call printf and say month, day, year. For month, day, year. And then we'll leave it at that, I guess. This is probably going to be rough. Let's give it a shot, though. Too few args. Expected 5. Semicolon. My bad. Always got these syntax errors. I did a colon. Oh, what's going on? Oh. What am I doing? I don't have... Dude, I am terrible at coding. expression. This else is expecting an expression? I thought we could just do... expected expression. Expected expression. What am I missing here? Am I dumb? Oh. No, I'm not doing a condition. I'm just doing a set. Else this. Oh. There we go. There's an error with my syntax. What do you know? Okay. No, wait, did we get it? Wow, okay. So that printed out December 31st, 2026, the 366th day of 2026. Oh, no way, we got it. Wow. Wow, I'm kind of like shocked. I was expecting a lot of error there. But the bit we just had syntax errors. That's it. Do we really get it? That would make sense. Let me do the 23rd day. Let me do my birthday. Let's see if it works. Let's try that case. Ah, here we go. No. 12 negative 8, 2026. Oh, okay, so that would do the remainder. So it's not days remaining, it's to day of the year. There we go. Oh, whoops, not there. Sorry. Not there. That's right. It's days of the year here. Right, it becomes negative, it's there. Let me go back. There we go. Why is that giving me 12 for the year? Or for the month? I equals to 0. If the remaining days, so day of the year is 23 minus 31, that would give me a negative value. Right, minus 8. Remaining days. Remaining days is less than 0. So the month goes up. Oh, then it keeps going because remaining days is 0. Okay, so then we need to break. It's over. We have to break. Right, we've already set. There we go. It kept looping all the way through 12, and then because it hit that there's no remaining days, or that's less than 0, and kept hitting this over and over again, increasing all the way to the end of the array. There we go. I think that is our final solution for this. What do we think? Let's get some feedback here. Let's get some feedback. Oh. Year mod 400 and year mod 100 equals 0. Or, oh, so we just have a little bit of an error here. This has to have a parenthesis here, right? The problem is the year mod 400 is never being treated like a Boolean. Any non-zero value is true. Oh, yeah, right, because I need to do is equal to 0. I think I just missed that part, the equal to 0. I just didn't type it out. We for sure, though, knew that. You would think. Okay, let's try that. So 31. So we'd be kind of like at like the, you know, let's just do let's say that we're at like the 57th day of the year. That's 226. 9th day of the year. 228. Okay. And the 60th day of the year should be March 1st, 3 of 1. Now the 60th day of the year in a leap year, which I believe was last 2 years ago. Probably divisible by 4, right? Boom! Yes. Leap year logic is working. And then the 61st day of the year will be March. Oh, let's go! We got it right. Wow. I'm thrilled. Let's go. That's crazy. Let's go. Right, so the year has to be divisible by 4, and it cannot be divisible by 100. But if it is divisible by 100, if this comes out to be false, we can do a check if it's divisible by 400. If that's the case, it's still considered a leap year as a final catch-all. If this one causes it to fail on this one is true. Right, so that changes us to 29. We were good in, coming up with the idea or just identifying to use an array here of month, days to house our array data structure here to house our days of the month. And then, yeah, cool. All right, number 8, last one here. Write the following function. Int star find the largest. Int array a, int n. When passed an array of length n, the function will return a pointer to the largest element. Okay? Let's include the standard io.h. Let's go ahead and do int star find largest. Oh, I did it again. Given an int array a and an integer n. Okay, I'm trying to think. I've never had to do a function like this before, returning as a pointer. We're gonna say set the largest to array index of 0. If array index of I is greater than the largest, then what we're gonna do is set largest equal to the array index of I. That'll take care of that. Right. And we need to return a pointer to the largest element in array A. So we need to return, oh, hold on. Largest is going to be a pointer, int star largest, and this is going to be a pointer to the address value at array index of 0. And then we're going to say that if largest is greater than the dereference value at largest pointer, the dereference value at largest is equal to the array. And we're going to return largest, which will be a pointer to the value in the array A that is the largest value. So now if we have int main void and do int, or we don't even need to do that. We just need, we need int array A, which is equal to, let's just say 0, 1, 2, 3, 4, 5. Let's do int n is equal to the size of the array A over the size of the array A index of 0. We then have, we're going to call the star int star largest is equal to the return of find largest for A and N. Should be colon. Printf try it. Let's go. Let's get some feedback on that one really quickly. I think we got it. But you made a subtle mistake that completely changed what the function does. You want to move the pointer, not the value. Oh, we want to move the pointer, not the value. So the largest is equal to the new address at I. Right, we did the int star largest here because we're just initializing or declaring largest as a pointer. And at the same time, we are initializing or defining it to the address at array index 0. Now, we need to still define the address here to change. And that still works. So we should probably, though, add if n is equal to 0, we're going to return null. Okay, cool. That wasn't that bad. That makes a lot of sense, right? We weren't wanting to override the value to that largest address, right? We were overriding like the address would happen to be that value in that array, right? We needed to actually just override the address value that's being housed in pointer largest, not the value, like by putting star largest here for that continued same address, which was a index 0. So we were really overriding the largest to be a index 0. Okay, that makes a lot of sense. Perfect. All right, you guys. Thank you guys so much for being here. Yeah, if you modify the address pointed to the largest, then print the array should be reflected in the array. Yeah, exactly. It probably would show the largest being overridden as the first index. Cool, you guys. Thanks so much for being here. Or whatever that index of that array. Well, yeah, it would. First index, because that's what it's pulling from at the very start. Cool. That ends up wrapping up our exercises here for pointers in chapter 11. Definitely probably need to take a stab at maybe doing I'll probably maybe do half the programming projects, 2 of them on stream. Oh my gosh, what's up with this hat look? Holy cow, you guys didn't tell me I have I got like the yarmulke going on. What in the world? That was embarrassing. That was a bad look. Okay. So, program modified projects in 7 from chapter 2 includes the following functions. It's just modifying these old projects, which are really annoying, honestly. That's why I don't really like these programming projects anymore, because rather than creating projects from scratch, you're having to go back through your old projects and rewrite your previously written code into more optimized, with pointers and whatnot, which, is kind of annoying because I'd rather just restart it from scratch. But it's like, whatever. And then you have to kind of go back in the book, and with scrolling, it makes it really annoying. I'm just being annoying, but annoying. I say that a lot. Anywho, thanks so much for being here tonight, you guys. I appreciate you. This was a lot of fun. Going through completing the rest of the exercises. So we completed all 8 exercises here of C Programming, A Modern Approach, 2nd edition by K.N. King. All my answers to these exercises and programming projects are on my GitHub for free, linked down below. Make sure you guys check those out if you're wanting to reference them, along with my notes and other things. Finish. chapter 8 exercises. Cool. All right, and we'll push that up. Cool. How long have I been streaming for? It doesn't tell me anymore at the bottom of my. Oh, yes, it does. Hour 45. Oh, it's probably a while. Okay, make sure you subscribe, and I'll see you guys tomorrow. Like the stream if you enjoyed. Make sure to come back and do more See You Tomorrow with me. I'm really trying to focus on getting through the book and getting through the large majority of this book and whatnot. But I've got a lot to go. Obviously, we're only on page, what, 256. There's like, we're chapter 12. There's pages all the way to 600. Oh boy. Oh boy. Thanks so much for being here. I appreciate you guys. I'll see you guys tomorrow. Have a good one.